This is a video overview of LapseAnalyzer, which is a web-based analytics tool for generating and sharing visualizations of data gathered from smoking cessation studies. This tool sports a variety of representations of this data that are designed to highlight different kinds of information and to facilitate discovery of patterns among the study's participants. Studying this data and uncovering such patterns is crucial to understanding why people who quit smoking succumb to events of lapse, and will allow researchers to develop models for predicting when a person is about to experience a lapse, as well as when the optimal time is and what the optimal means are to intervene and prevent the lapse from happening in the first place. Now, the app is divided into two sections. The left side is where visualization parameters are chosen, and the right side is where the chosen graph will show up. Initially, a welcome message is shown that indicates directions on how to start picking a graph. In the visualization selector, the available options are numbered and listed in order. The second option, where the type of visualization is chosen, features options that are partitioned into two groups. Individual graphs are intended for individual participants in the study to assess and reflect on their own data, while comparison graphs are designed for researchers to examine the data of one or more participants in the dataset at the same time, to identify similarities and differences between these data points and their contexts. Some options, such as the participant selector down here, are only displayed when certain visualization types are selected. As you can see, it changes to a different option or goes away when it's no longer relevant. Once the desired graph options are chosen, click the button labeled Generate at the bottom to produce the graph. Notice that the URL displayed in this web browser changed when the graph showed up. If you save this URL, and type it in again later, or share it with another user with access to this web app, it can be used to access the same graph with the same options selected, without needing to manually pick the parameters again. There is also a full screen option that displays the graph on a page where the sidebar is hidden. The URL that this produces is useful for sending to other users who only need to see the graph and do not need to mess with the graph's parameters. Now let's take a look at some of these visualizations. The heat map, which we've already selected and displayed over here, represents stress intensity data of an individual participant over time using a color scale. This style of visualization is great for discovering temporal patterns in time-based data, and can show large volumes of data in a succinct manner. There is one row in the graph for every day of data recorded during the study, and one column for every hour there is data available. These days are partitioned into two groups based on the participant's quit date. The gray background indicates data recorded before the quit date, known as pre-quit data, and the light blue background indicates data recorded after the quit date, or post-quit data. The stress data itself is represented using thin vertical stripes, each of which contain an average of each minute of the participant's data. This data follows the color scale indicated in the legend below, where blue represents low stress, all the way up to red representing high stress. Hovering over an individual stripe of data shows an overlay of larger horizontal stripes, where each stripe represents an individual data point within the minute of data present under the cursor. Gray stripes indicate no data is available for that particular second. This graph also contains cigarette-shaped icons, each indicating a moment during the study when the participant lapsed and consumed even just a puff of a cigarette. Using all this information, we can see if a participant experiences periods of high stress at any specific dates and times in their study, such as here, where this participant experienced several spikes in stress intensity at around 11:45 a.m. and 12 p.m. on Monday, around 15 and 30 minutes respectively after the participant experienced a moment of lapse. The Scatterplot visualization bears many resemblances to the heat map, but uses a more traditional vertical line to represent stress, and is ideal for viewers who care more about examining minute-by-minute variation in a participant's data. Like in the heat map, the data is split into a row for each day and a column for each hour, and the background colors indicate the same temporal relations to the participant's quit date, and the cigarette icons mark the same moments of lapse this participant experienced. What differs here is that the height of these lines are now what indicate stress intensity. And now hovering over a point on the line, such as in that same Monday window near 12 p.m., reveals an overlay of the 60 or less data points recorded during that minute, where both color and height in the overlay indicate stress intensity. Moving on to comparison-focused visualizations, the average small multiple visualization has some extra options that can be chosen before generating the graph, such as picking which quit phase, pre-quit or post-quit, the data is drawn from for each participant, and in the event that the post-quit phase is chosen, which day that data is drawn from. The resulting visualization features a series of small graphs, one for each participant, that stack on top of each other and all refer to the same time-based scale seen along the bottom. Each graph is labeled with the corresponding participant's ID, and like in the scatter plot, a participant's stress intensity is indicated by the vertical height of the graph. In a case like this, you can scroll and see additional participants from the population. For example, if we align the mouse at 4 p.m. on the scale and scroll upwards, we see that this participant just above the cursor experienced some spikes in stress intensity at this time, as well as this participant, and this one did not, but this participant experienced some increased stress, as did this one. So a significant number of members of the population experienced some intense stress at this time of 4 p.m. The stacked bar chart visualization allows for multi-dimensional comparison, the two dimensions in question being comparison between participants in the population and comparison along a relative timescale. This relative timescale, which is shown along the y-axis, now means that data in this graph is aligned by each participant's quit date. The gray background here still denotes pre-quit date data, and the blue background still denotes post-quit date data. But this 24 in the blue area now refers to 24 hours after each participant's quit date, which is not necessarily the same date and time for everyone. Each participant's data is contained in its own column, and time increases as you move vertically up the graph. Each horizontal stripe in this data accounts for an average of the stress data recorded during that hour of the participant's study. For example, we can see here that 6 participants experienced a lapse about 1.5 days or 36 hours into their study, as well as up here that 6 participants experienced 2 or more moments of lapse between 24 and 48 hours after their quit date. The stream graph visualization uses event aligning to see if any general patterns can be found from highlighting intervals in the data. The event in this case is each participant's quit date, and this graph is only concerned with the first 3 days of data for each participant after their quit dates. Time here is once again represented using a relative scale seen along the bottom. So 12 hours or 1 day into the study is likely a different actual date and time for each participant. This graph features some parameters that can be adjusted after the graph is created, such as the zoom level of the x-axis, as well as the option to filter out participants from the graph using the checkboxes on the left. The checkbox with all in front of it will either show or hide all participants in the graph. Because this visualization uses a stream graph, stress values here are represented by the area that individual parts of the graph take up, rather than the height. At this point, for example, it may look like this participant's stress intensity was highest because it extends vertically the highest, but the area the data takes up is actually much smaller than the participant below it, meaning this lower participant experienced the greatest stress. Now you may have noticed that when you hover over data in this graph, the data point under the cursor is described by a small tooltip that appears nearby, and the participant's ID in the filter on the left side is highlighted with the color of the corresponding data in the graph. This representation means that areas of the graph that extend the furthest out vertically are where the most participants experienced high stress intensities, such as areas around here, and even in the area that I was looking at before. Noticing these spikes of overall population stress are a great place to start looking for patterns. The temporal event plot visualization displays only lapse events instead of stress intensity data, and aims to show whether time of day has an impact on susceptibility to lapse, and if there are particular times of the day where everyone is most at risk. The upper graph is dedicated to pre-quit date events, and the lower graph shows post-quit date events. Rows indicate which weekday, and columns indicate which hour of the day that these events took place. The color of the graph backgrounds are meant to illustrate the transition between daytime and nighttime hours. The color of individual events correspond to which participant, as they are listed in the middle here, experienced the event, and hovering over one of these participants in the middle area highlights all the events in the rest of the graph that participant experienced. Hovering over a single event square in the graph reveals more details about that particular event. It also highlights the corresponding participant in the middle area, and highlights other days where that participant experienced moments of lapse. And this has been an overview of the visualization generating, manipulating, and sharing features of LapseAnalyzer. Thank you for your time.